And hello YouTube, this is my Raylib C++ Minecraft clone. And we did all of this progress just in 7 hours yesterday. We rendered this terrain. And why did I experiment with C++? Well, if you look at the top left, it's hard to see. It's like it's those little numbers there. It's the FPS, and it's this 835 FPS. And let's look at the RAM. And the RAM is 176 megabytes. Now remember those values. We'll write them down. 176 megabyte RAM. This is what you get with C++ and Raylib. What I'm showing you now is why I'm so excited to make the Minecraft clone in C++ and Raylib. Now let's start the Java Minecraft clone. Now, obviously, the Java Minecraft clone has a lot more features, a lot more logic. It stores a lot more data for every block. But even so, this is the FPS. 80 FPS. 80 FPS. 10 times less FPS. 80. Look at it. Java. C++. Look at the difference. And now let's look at the RAM. Let's look at the RAM usage. The RAM, 5 gigabytes. 5 gigabytes of RAM. Like almost. 4.9. 4.9 gigabytes of RAM. Like, this is why I'm excited. 4.9 gigabyte RAM. Now, which one would you pick to make a Minecraft clone? Java or C++? Which one? And another reason that I got excited is by how much more enjoyable using C++ is. It's a lot, like, it's so much more enjoyable to use C++. And now, why did I start in Java when I showed you all of this? Well, I started actually in C++, and the problem was that I couldn't make much progress. And with Java, we made so much progress. But now, I've gotten some experience, and I feel like in this stream, we'll be able to make significant progress in C++. And so for this stream, I'm thinking of continuing the C++ Minecraft clone, and I'm just curious, where can we go? How far can we reach with the C++ Minecraft clone? And for how long this stream will be? Usually it's 3 hours, and yesterday the goal was 3 hours, but I streamed for 7 hours just because I enjoyed my time with C++, except all the compilation issues. And so now my goal is 3 hours for today, but anything is possible. We can reach maybe 8 as well. Now the first thing I want to change is when we hit play, look at how much time we need to wait. This is C++. Look at how much time. It's a lot more than in Java. A lot more. I want to change this. We're still waiting. We're still waiting. Now, finally, this was to generate the terrain, and it's too slow. It's too slow. So, what came to mind to change so that we can improve this is in the when we create the subchunks. When we create the subchunks, here I use this class position details and I give it just a position. I'll make a new constructor that takes because it takes a position, it calculates the block origin, local block position, subchunk origin. We don't need that when generating the terrain. So we could do vector3 subchunk origin to directly give it to this class instead of having to calculate it for every block. And I think this will make the generating the terrain a lot faster. Local block position. This is the easiest change we can make, the fastest change. This is the fastest change. Actually, yeah. So subchunk origin. We could do it here. Subchunk origin, and local block position, and that's it. And so when we generate the subchunk here, we can give it the subchunk origin and the local block position. And we need to also set the block origin. So block origin will be it's simple, it's the subchunk origin plus local block position, and that's it. And here I like this in C++ because in Java I would have to do new vector3f, but now you shouldn't do this because it has to be coming from an object pool, because the garbage collector will have a hard time handling it. And in C++ you just do this and everything is fine, hopefully. Next, let's see how much faster this change made terrain generation. We cannot make it instant since everything's running on the main thread, so we could improve it even more when we add threads. But still, I wanted to see if we get an improvement. Well, I'm not sure how faster it was. Yeah, so we can move on to threads probably. We can probably move on to threads. And we already have I can reuse code from my previous C++ Minecraft clone, which is this. There I have a thread pool, this. We can just move it. It's just a few simple functions. We can move it here. And GitHub, let's do a commit. And can create position details by giving it all members info. That's it. And so here we create a new header file, thread pool header, and now we give it this. We don't need this, and that's it. So here we just have a function to create a thread pool, to destroy it, and to enqueue functions to be executed by an available thread. That's it. Thread pool cpp. Thread pool cpp. And I'm copying just the previous code from my previous Minecraft clone. Now here I don't need this. Yeah, I think that's it. This was from a tutorial. There's a tutorial on the internet on how to create a thread pool, and that's where this code is from. I don't need this. And so does it compile here. Here we create the thread pool. I need to include it. And here, what's the issue? Thread pool. Thread pool. Yeah, what's the issue? Oh yeah, there's a spelling mistake. Thread pool. And so here, create thread pool. Let's say 4 threads. And here, thread pool, destroy thread pool. And that's it. Now does it run? Where is the issue? Linking error. Unresolved external symbol. Create. Oh, let's update the CMake. Yeah, now it runs. Yeah, it still takes a lot of time. Actually, let's clock in how much time it takes. I'll prepare a timer. I'm running the timer. 3 seconds, 4, 7 seconds, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 seconds to generate this. 18 seconds. Let's remember it. 18 seconds. And how much for the Java Minecraft clone? Because I think it's faster in Java. 1, 2, 3, 4, 5, 6, 7. 7 seconds. A lot faster. 7 seconds. Versus 7 seconds. Man, more than double the difference. Before we because I was thinking of using the threads to improve it, but since we can improve it by double the speed without threads, we can try to do that and then we'll add the threads. So how can we improve it? Here, generating blocks. So I go on the X and Z, I generate the noise. Then I go on the Y and fill it up. Which part is the slowest? Let's comment out. Let's comment out these parts. Let's comment out these parts. It's done. Really? Huh. The slowest part. Okay, let's uncomment this. Generate mesh. Yeah, generate mesh is the slowest. Look at how slow generate meshes. Another thing we could do for improvement is to use Tracy. Since Tracy will show exactly where the slowdown is. It's a profiler. Generate mesh. And what happens in generate mesh that it slows it down so much? So we go through every sub chunk and here, oh, I get it. No, I don't get it, because here let me think about it. Current block type. One improvement we can do is to bring up this to be at the very beginning. If it's air, where we continue. And here we can do blocks. Get index position to index X, Y, and Z. This would probably be an improvement. But it's not that much of an improvement. Yeah, not that much. It's not that much of an improvement. And where's the slowest part? For each block that's not air, we go over the neighbors. But it's the same as in the other Minecraft clone. We go over the neighbors. And then we fill up this mesh template. And then we generate. Actually, here... No. I was thinking of doing if there is no culling to continue, but no. Here actually we can do if mesh template positions face current face equals 0 to continue, which would be the same here. It's not that big of an improvement. Here 0 times 4, yeah. It wouldn't be that much of an improvement. It's not that much of an improvement. We can use Trace. Trace. Where, in which project have I used it? Yeah, I think in the voxel. In the C++ easy. Well, I think every project is hard in its own way. C++ is hard in like trying to compile everything and has maybe a little bit of a steeper learning curve. And another reason it's hard is because you have access to a lot more. You can go to a low level. But Java is hard as well, since Yeah, you have a garbage collector, but you still have to be mindful and a lot more careful with the objects you create. Like, you don't have complete freedom to do whatever you want. I need to move the... I need a profiler. And I have profiler in my old C++ project. Here in Voxel engine, vendor, Tracy. Here, let's get it. Open File Explorer, vendor, Tracy. This is what we need. And so here, let's give it to my new project. So we can have a profiler. Does it have CMake? Yes. It has CMake, so let's update the include. Think about it. Add subdirectory. We need to add trace. Yeah, we filed Tracy. Does it have some kind of includes? Tracy. Does it have an include folder that we need to include? I don't see one. So now let's try to use it. Here. Tracy. Tracy is the best profiler for C++. It's the best. Everybody uses it. I think even Unity uses it. Because I've seen its profiler and it looks a lot like Tracy. But I need to see how did I use it. I'll have to go back in the engine. And in the source code, where did I use it? Core. Is it in log? Yeah, in log. Here. Get core logger, I think. How to use Tracy? How to use Tracy? No, this is different. No, this is for logging in the terminal. Where do they use Tracy? Let's do a global search. PCH. No, this is a precompiled header. And what's this? This is a define for Tracy enable. We can do it here in the globals to enable Tracy. Sure. And do we have an include of that? Here we have an include. Here we have an include. We can put it here. We can put it here, and what's the issue? This is in vendor, Tracy, Tracy.hpp. Public, Tracy. Also, I need to include this public folder. Yeah. And that will give me Tracy. So here Tracy public, and that will solve it. Yeah, that solved it. And I need... What do I need? Here, the profiler. I think I directly used... this is in Tracey public. So where have I used where have I used Tracey? I think it's this profile function. Zone scoped. Yeah, these, I think it's these ones. Yeah, this is in Tracey. So profile scope and profile function. Yeah, that's it. I'll just copy these here and remove this voxel engine. So profile scope and profile function. And so let's go back to main. And let's do profile scope. Main loop. And what else? And here generate mesh. Let's profile this function. We can actually just create a smaller scope here, smaller scope here, and here to profile this scope, profile scope, and call this generating all mesh, generating all models, and here profile function, and here profile function, and here profile function. And where do I use it? So I can profile the scope as well. Here. Like this. And so here is generating all blocks. And does it run? The most important part. This profiler will be extreme. This is another reason I wanted to go to C++, is because of Tracey, since it's so helpful in profiling. Okay, it runs. And so now let's download Tracey because I need a client. Tracey client. Maybe it hasn't a release. Maybe this. Okay, it's most likely that. Tracey. So we move it here. And you should have a client. Yeah, maybe it's this. No. Yeah, this is the profiler, and it needs to connect. It needs to connect. And so now so let's start it and press connect. It says it's waiting for connection. It's waiting for connection, so it's not connecting. Yeah, it's not connecting. Oh, I have to see what else I have configured for Tracy. Here. Microsoft, no, not this. The engine. This. Properties. Let's look at here. The preprocessor. What do I have here? Include non debug. No, nothing here. General. No, not this. Precompile headers, not this. What about the other project? Preprocessor. No. Okay, we can look at the voxel engine. We can look at the pre-make. We can look at the pre-make and see what do I have configured for Tracy. Tracy. Nothing for Tracy. Let's look at my the same voxel engine project that I had with CMake. Was it this? Yeah, it's most likely this. And then about in the engine, link libraries. Yeah, am I linking actually the library? Yeah, let me think about it. Am I linking it? Oh my god, I'm not linking the library. Oh man, that's such a rookie mistake. It's actually Tracy client, like that. Here was the issue. Think about it. Find all. Oh, I have to have this. Profile. Profile zone. What about profile zone? Profile scope. Is it the same there? Yeah, I need to have this. Need to have this. The semicolon at the end. Is that all of them? Yes! It's working. It's working. This is it's generating mesh. Now it's generating models, and that was it. And that was it. Yes. The profiler is working. It's working. Now, let's look at it. Now, this is for generating the blocks, which took 391 milliseconds. And how much that is in seconds? Is it even a second? 2 seconds. 3.91. 3.391. No, it's 391. 391. So it's not even a second. Generating the blocks doesn't take even a second. And now generating all the mesh takes 12 seconds to generate the mesh. And here it's for one subchunk mesh generation. It takes 6 milliseconds for each subchunk, and there are a lot of subchunks. Man, I love this profiler. It's so cool. This is to generate all of them. This is, yeah, there are slight differences, but around 6 milliseconds to generate every subchunk its mesh. What about here? Yeah, still the same. This is to generate all the mesh, and now generating all the models. To generate model, it's a lot faster. 1.4 milliseconds. It's a lot faster. And then is the main loop. Then is the main loop. The main loop is 1 millisecond. So if we want to make loading the terrain faster, we will need to fix generating all mesh. Generate mesh takes a lot of time. Okay. We can make it temporarily faster. Int world width. Const world depth, world height. This was 10. We can temporarily even render just one subchunk. It's not an issue. Yeah, we can temporarily do even just one subchunk. That would be enough. So we can see if we can make improvements to mesh generation, how much time it takes. The profiler is stopped. How can we continue it? Yeah, let's continue it. And what did we get? generating mesh is a bit faster. Let's do a bit more meshes actually. Like 100. But we need to bring back the client. Like this. So here, how much is it? It's quite fast actually. When it's just 100 some chunks, it's quite fast. Yo, hello, Quake Arena Hacker. Right now I'm profiling the project. Yeah, you want me to go in Bulgarian, but there are other people that don't know Bulgarian, and I want everyone to understand. Like I had a viewer from yesterday and the day before that, all the viewers were from Turkey, and they join every stream. And when they join, I want them to understand what's happening. And there is a vote in YouTube of the stream is saved. So a lot of people rewatch it, like 100 people rewatch every stream, and I can bet, like, and look at the statistics, most people that rewatch the votes are like from the United States. Like, I cannot afford to like lock in just my native language. I want to grow the channel, because if I just speak in Bulgarian, the channel will not survive long. Yeah, let's increase the sub chunks to be 400. Yeah, but let's restart the profiler. Discard, reconnect, like this. Start again. Like this. So, what do we get? Generating blocks, 38 milliseconds. Yeah, that's okay. Generating all the mesh, almost a second. Yeah, that's absolutely not an issue. But if we increase it to like even more sub chunks, it gets slower than Java. Like, that's my main issue. It's slower than Java for generating the world. Where's Tracy? Did I close Tracy again? Connect. Yeah, let's start again. I want to see where is the slowest part. Okay, generated. Here. What is the slowest part? Yeah, generating all mesh, now it's 5 seconds. That's a big increase. And generating some mesh. When do they become 6 milliseconds to generate a subchunk mesh? When does that happen? Because at the start, look at it. At the start is also 6 milliseconds. It's sad that I don't have a profiler for Java to compare how much it takes to generate a mesh there. 6 milliseconds. Can we generate mesh for one sub chunk for less than 6 milliseconds. If we can do that, we can catch up to Java, because right now it takes 18 seconds in C++, but in Java it's just 7 seconds, and I cannot accept that. But the other improvements we got was, here in C++ we had 10 times more FPS and just 100 megabyte of RAM, but in Java 80 FPS and almost 5 gigabyte of RAM. We improved a lot switching to C++, but the generation of the terrain just takes up so much time. And this is on the Raylib side. Before I was directly using OpenGL, but here I am abstract using Raylib, and maybe Raylib is slowing me down. So what I want to see is it worth relying on Raylib, because this is a big slowdown and I cannot accept it. Here we generate all the mesh. Chunk size the same. Each subchunk is 16 by 16 by 16. Every subchunk is the same. Yeah, okay, this is the function itself. We can profile it even more. I want to see here where we go over all the neighbors. We can profile this part to see how much time it takes. Here, profile scope. We can profile just this part. What should we call it? Go through neighbors. Yeah, but this is just for one block. This is just for one block. Yeah, I should do it before this. I should do it before this, because this is just for one block. It's too granular. We can do it here. Go through all solid blocks. Go through all blocks. Yeah, we can do this. And here is the end of the scope. And this will be profiled. But we can profile it even here. Why not? We can do one even here where we go over all the neighbors. It's not an issue. It's not that big of an issue. Go through current block neighbors. We can profile this part as well. And we should end it here. And we can do another one. Current block. I need access to this current block since it's now out of scope. I need access to it here. But I can save the vector3 local block position to be this, and I can give it here, and I can give it here. Okay, and what else should I profile? Here maybe, creating the mesh. Yeah, we can profile this. Can profile this. I mean, if it's literally the same code, the C++ version should be faster. Yes, obviously, C++ should be faster, but it's not the same code since Java is only using OpenGL. And here I am using Raylib, which adds abstraction, and they do things differently, but they still use OpenGL, so there is a chance I can reach the Java time. Profile the time it takes the CPU to upload the mesh. I'll profile that as well. Here, mesh preparation. And actually, uploading the mesh happens in the other function. So, and we're trying to improve this function. So we'll look at it later. Mesh preparation. And that's it. And let's restart this. Discard, reconnect. And let's start it. Now we wait. Okay, we have the data. Perfect. Now let's see what's happening. And look at how generating all the mesh takes 5 seconds. It's the most amount of time. And like I've made the world smaller, and that's why it's 5 seconds. But if I make it like as big as in Java, this will be 12 seconds. So let's see what's up. This is generating, this is the function generating the subchunk mesh. And what's going on? Going through all the blocks. This is almost all of the, so going through all the blocks is what takes the most amount of time. Wait a minute. So here, and this is just the for loop, right? No. Yeah. It's the for loop. So the for loop takes the most amount of time. Right? Do we have anything here? We should have go through block neighbors, yeah. But generate mesh, there was another call. Where is it? There was, like here we have go through all neighbors, sure, and it takes a lot of time, yeah. But here we should have mesh preparation. Is this like super small part of it? Where is it? Generate mesh. This is going through all the blocks. Is it like super small? Where is it? It should be somewhere here. And it's nowhere to be found. Maybe it's too small. Or it's super close to this. It's not here. But obviously, like, what took the most amount of time was when we go through all the blocks. That's what takes up the most amount of time. Go through neighbors. Go through current block neighbors. Go through current block neighbors. And here, okay. And it makes sense why this is the slowest part, since I did something different than in Java. Actually, this is my, like, my bad. This is my bad, since I have this class position details that simplifies going through the neighbors. Here I have functions that go up, go down, etc. It simplifies finding 6 neighbors. Here I'm looking for every block, the 6 neighbors, to see if they're air or not, so that I can cull faces. And they made it easier for me since the neighbor can be in separate chunk, a separate sub-chunk actually. And each sub-chunk has only its own blocks. And if I have to get the neighbor and it's from another sub-chunk, I have to communicate with it. And this class simplified the process, and it made the code a lot cleaner than in the Java. In Java I did it differently, and obviously in Java actually it's the better approach. So maybe I have to just copy what I do in Java, even though it's a bit more code. Where did I have it? Subchunk. Here. Here I get the neighbors. And it's just this function. I'll just copy this function. And I beforehand get the neighboring subchunks. Interesting. Yeah, I get the neighboring subchunks beforehand. Yeah, I'll do this. I'll just copy what I do in Java, and this will probably make it faster, even though it's more code. Since that's what the profiler is telling me. Look at how for generating the mesh, the most amount of time is spent going through all the blocks. Yeah, that's what the profiler is telling me. And that's how we get... Oh, what's this? No. And that's why we get so much waiting time for generating the mesh. Generating all the models where we actually upload the mesh is not that bad. It's not that bad. Yeah, so let's just replicate the Java code in C++. And add trace. Now let's commit adding Tracy, which is the profiler. And now let's replicate how we iterate through neighbors from Java. So here from the start, I want access to the neighboring subchunks. Yeah, so subchunk, it will be pointer maybe. This will be top subchunk neighbor, and this will be, let me think about it. And maybe we could have this be unordered map, since it's cleaner like that. Include unordered map where the keys will be strings, because I'll have to pass this information to a function. Unordered map of, and I have to include strings like this, and here string and subchunk pointer neighbor subchunks. What's the issue? std unordered map Do I need this? Okay, I need the STD. Yeah, and so here, let me think about it. I need to put references to the neighboring subchunks of the current subchunk, sure, but and I can use strings as keys, but let me think about it. It's better to use enums since in strings it's easy to make mistakes. We could have here in globals. How do we do enum? Enum C++. With numbers, I want them to have, enum. Yeah, let's do enum direction top. How do they give numbers? Like this. And here I had direction as well. Direction. Direction, I had them with values. And I wanted to copy them, but it's not that big of an issue. Subchunk. Yeah, so top, let's do 1. Down is 2. North is 4. South is 8. West is 16 probably. East is 32 probably. 6, yeah. It could have been just a define. It can be just a define. Yeah, why not just a define? Can be just a define. Like this. And I did all of that since here now we can use integers. And now we can do neighbor subchunks. Can I do it top? The top subchunk to be world get. Do I have the world? I need to include it. World get subchunks and we think about it. Where is position details? Here I got, I need to do a find. I need to do a find. I need to do a find. And so here, for all of them, here I do, let's, yeah, I need here the subchunk origin. Here I'll give it an offset, sure, for the top, and that's easy, like plus like And this is for top, so 0 subchunk size 0, like that should be it. A vector 3, yeah. And if it finds it, I'll save the reference here. I'll save the reference here, top equals the subchunk reference, which is this. Sure. And if it doesn't find it, to be, let's say, null. We could do that. Or we could do in the world here static subchunk pointer, get subchunk, and here vector 3 origin, and create definition, and here to do the same thing here. Where is the world? Here. And here to return null pointer. And here to return this. Origin. Like that. And here in subchunk, to just do equal world get subchunk and subchunk origin plus vector vector 3, or what functions does Relib have? Vector 3 adds two vectors. No. We can just do it like this. So 0 size 0. This is the top neighbor. This is the top neighbor. And yeah, it executes, but I need to be right back. I need like 2 minutes. I'm back. Now, let's do this. Yeah, music is here. Now, let's continue the like going through all the blocks to generate the mesh to make it as fast as Java, or to see if it will get even faster. So we get the neighbors beforehand. So 1, 2, 3, 4, 5, 6 down, north, south, east, west, and here it's minus size. Let me think about it. Let me think about it. Here north is on the Z. It's on the Z. But minus size. And here it's size. And now for east. For east it's plus. For east it's plus size. And for west it's minus size. That's it. And so now we need to get the neighbor block data. Let me think about it. By giving it normal and current position, let me think about it. Yeah, we'll remove this position details. Let me think about it. Yeah, I need a function. Here. And it needs to return an integer. Get neighbor block data. And it needs vector 3. Here it should be reference actually. Even a const reference. Man, this will make an error. I need... what do I need? I need the normal. Before that, vector 3 local block position. And I need the... Man, I'll have to move it. The unordered map. Const. Let me think about it. Here. I need to move it here. And here I'll need const std unordered map of integer to subchunk reference neighboring subchunks. That's it. And let's implement it. Get neighbor data. And so here data the data, if it's 0, it's air, if it's 1, it's a grass block. So now we need to go over let me think about it. How do I do it in Java? In Java, I give the local block position and the normal. Oh, I get it. Yeah, I get it. So if the normal y equals 1 and the local block position y equals size -1, yeah, but in Java I directly do top like the chunk neighbor get block data, sure. But here it can be null pointer if it's missing. And how I solved that in Java, I had an empty chunk, empty subchunk that I used as a reference when there is no subchunk, to simplify it. Can I do the same in C++? So I could create a subchunk that has block data filled with zeros. I could have that. But when we add endless terrain, there won't be this problem. This problem won't be there. Let me think about it. I could have just create a variable. Yo, hello. What's up? Here I'm going through the neighboring subchunks. I could create a subchunk pointer to a subchunk neighboring subchunk, and here if we're in this case, I could set it to be like neighboring. Where is it? Neighboring subchunks. I could set it here. I could set it here like this. This is the top. Right? What's the issue? It takes an integer. Top is an integer. Neighboring subchunks. Yo, what's up? Yeah, I've made the dual stream so it's easy for viewers to pick where they want to watch. For some, Twitch is the better platform for live streams. I could have this as const. What's the issue? Trying to get the top neighboring. Oh, come on, man. This was so much easier in Java. But it's worth it. The pain with using C++ is worth it since we got where is it? Since we got this huge improvement, like with C++ 800 FPS, with Java 80. It's a huge improvement. It's worth it. The pain here is worth it. It's worth it to figure this out on how to do it with C++. Let's... Here I'm trying to access it. Okay, what if I remove the const? Yeah, that changes it. So I'll remove the const here as well. No problem. So we get the top neighboring subchunk, else if the normal y is -1, then we're looking for the bottom subchunk, the bottom neighbor. And if the local block, the current block is like 0, then for sure we'll need to get the bottom subchunk down, and we need to do the same for z if it's 1, and if z is size -1, this should be if z is, where is it? If the normal z is 1 and z is the subchunk size -1, yeah, we need the south. Now let's do the same for north. If it's -1 and this is 0, we need north. And then on the x-axis, we need to do the same. Here, if x is -1 of the normal, where is the normal? If x is -1 and x is 0 of the current block position, we need the west. We need the west subchunk neighbor. And if it's 1, we need the east. And here if it's size -1. Sure. Else, here we just return. Let me think about it. We just need the current block date. Yeah, so we need from blocks position to index, which is the local block position plus the normal. That's it. And since if we are here, that means we haven't reached here. So here if neighboring subchunk is not a null pointer, else so here by default the neighbor will be a 1. Here if we are here, that means we need access to a neighboring subchunk, and if it's not a null pointer, we need to do this. What do we need? Let me think about it. Let me think about it. We need another vector tree. neighbor local block position. Let's copy the current block local position, because here we need to change it. Here it needs to be this is for the top. Here the y needs to be 0. Here the y needs to be size -1. And here the z needs to be that, and here the x needs to be size -1. And here it needs to be the z 0, and here the x 0. Neighbor. And so here we return, here it will be just return 1. So I'll remove this. Here the return will be neighboring subchunk blocks, position to index is the neighbor local block position. That's it. That should be the function. Man, that was so much. And so here, where is it? Where we get all the neighbors. We don't need this. We don't need this. And so, do we use the neighbor anywhere else? No. Let me think about it. Here, we need to use the function we created. Get neighboring block data. Here, we give it the local block position. Here the normal is 0, 1, 0. And here we need to give it the neighboring subchunks. That's it. That's it. Here we need to go down. Here we need to go north. What's the issue? Oh, yeah. I don't need this neighbor. I don't need this neighbor. Don't need this neighbor. I don't need this. And so here we need to go down. Here is the north. The north, it needs to be -1 on the z. Not here. Here. Let's actually do 0 so we can copy it cleaner. And here -1 on the z. Here. Here. So the south is 1 on the z. The east is 1 on the x. And here it's -1. That should be it. Now this should be faster. Let's see. First we have to see if it works. It works. And now let's look at the profiler. The profiler. Where is it? Here. Let's restart it. Let's start this. Let's see if we made an improvement all of this work. Let's see if we made an improvement. Generating all mesh took 1 second, and I think before it was 5 seconds. Now let's look at... To generate one mesh, before it was 6 milliseconds, now it's 1 millisecond. Yeah, now I think it's a lot faster. Now I think it's a lot faster. And so now we can do... So generating the mesh took 1 second, generating the models 1 second, something like that. So now we can do the bigger world size, just like in Java. So here 10. We need 10 here. And we restart the profiler. Discard, reconnect. And I'll prepare a timer. I'll prepare a timer. We need to beat around 8 seconds or 7 seconds. One, 2, 3, 4, 5. Around 6 seconds. Yeah, now it's like Java. Now it's like Java. Now it's faster. Before this was like 12 seconds, now it's 3 seconds generating all the mesh. So this is okay. Generating all blocks. So from here to generating all models, 6 seconds, yeah, around there. Yeah, now it's faster than Java, even generating the terrain. It took 6 seconds. Yeah. Before it was 18 seconds, now it's even faster than Java. Now it's faster than Java. We did our job. We did the job. Will the movement in this version also be like source movement? Of course. Yeah, of course. Like, where? That's obvious, yeah. Like, I'm not going anywhere without the source movement. Let's commit it. How should I name this commit? Faster terrain generation. Push. Yeah, now it's like 6 seconds to generate the terrain. And this is without using threads. This is without threads. Now the next thing I would really want is to use threads so that it opens up instantly and we can look at in real time the world generating. That would be super cool. That would be really cool if we manage to do that, since we don't have that in Java. That would be really cool. If we manage to do that. And here Raylib offers this cool like logging ability where you can see everything that happens right inside the console. Here it shows that it uploads the mesh successfully, and here when I end the game I unload all the models and meshes. Everything is cleaned up properly. Let's look at the RAM actually. Is it still the same? The RAM, we will increase the RAM for sure, because right now every block is just an integer. But I'll need more data for each block, because each block needs to have information of the light data. Is a game running currently? Yeah, I need to close this. Each block will need to have more data. And so the RAM will increase. But right now, this is the best it will be, the RAM usage. Where is it? Okay, right now it's... Okay, before it was 100 megabytes. Now it's 700. Why? What changed? Yeah, what changed? Before it was 100. Yeah, that's weird. Well, 700 is still better than 4 or 5 gigabytes, so... Oh, maybe because of Tracy. Maybe because of Tracy. Maybe. Is it possible to disable Tracy anywhere? Tracy enable. Where is this? This is inside of Tracy. Enable profiling. So if I put off here, and if I discard the changes and reconnect, and if we start it, and let's see if there's a change in the RAM. That would be interesting. So how much is the RAM? The RAM is 248. Okay, I get it. Yeah, it's Tracy. And if we look at Tracy... Oh, it's still... What? It was still working. Even though I disabled it. Huh. Generating all blocks. Even though I disabled it. That's weird. Yo, we have chat. Yo, what's up, Lumi? Yeah, I thought I disabled it here. Okay, if now it's on, we enable the profiler. Is there a change in the RAM usage? Yeah, now it's a lot more. The RAM usage. Almost a gigabyte by enabling the profiler. Yeah, there is a difference. Yeah, so now... how is your game progress? Well, the game progress, we have terrain generation, and it's... terrain generation is faster than my Java clone. The FPS is 10 times more than the Java clone, and the RAM usage is like way better than the Java clone, but we don't have all the features that the Java clone has. We're behind, but I think we'll catch up really quickly. We'll catch up really quickly. Because I really like C++ and Relic. Like, last stream it was 7 hours. And because in Java, I just wanted to do one simple change of giving the skeleton a bow. Just giving the skeleton a bow took me 3 hours. And I was like, okay, we're going to C++. Something is off. Yeah, so here, now, I want to see... Can we make it asynchronous? Like, can we generate the terrain on a separate thread? That's what I want. And we included this thread pool. We have this thread pool that can accept functions that it can do outside of the main loop, outside of the main thread. We can do that. But how actually? So, if we do that, we'll need to do some management. Because what I want right now is... what's up? Porting the features shouldn't be hard. Yeah, it should be very fast. Because before, the most amount of time was spent on figuring out how to do it. and to manage through the mess that the whole project is. But here the project is way cleaner, so I think here we'll have a better time. I think we'll be able to catch up very quickly. Here, what I want, look at it now. When I start the game, everything is running on the main thread, and I have to wait for the whole terrain to generate. And what I want is this terrain generation to happen on a separate thread so that the game can start instantly. That's what I want right now. I've done it before in C++ with threads. I've done it before, so here we should be able to do it as well. What I'm wondering is, what should I make a change in my approach? Should I make a change? How should we approach this? One idea that I have is we can have a place that holds data, like for all the possible subchunks we can have. Because here in main we have 20 by 20 by 10 subchunks. We have at all times we have 20 by 20 by 10, 4,000 maybe, yeah, 4,000. At all times we have 4,000 subchunks. And in the future we'll have infinite, endless terrain. And so the best approach for implementing that, like we have to think of the future when making changes now. The best approach to do that, like the easiest approach is to, like the data needs to be, what's the word? Where is it? It needs to be allocated. The data needs to be allocated, and allocating data and freeing up data all the time when generating new chunks is slow. So if we are going to use threads right now so that this terrain generation happens separately and we can instantly start playing the game, for that to happen, I think we need to separate the data from this subchunk class. I think we need to separate the data to allocate it once and to reuse it. Only then I think we can more easily implement separate threads for generating the terrain and handling it. And I'm wondering if I should go that approach. That's what I'm wondering. I'm thinking about it. Right now, the data of all the blocks is inside of each subchunk here. It's a dynamic array with fixed size, 16 by 16 by 16. It's on the heap and it happens. Where do I create it? Yeah, in the constructor, I allocate the data. But when we add threads, when we make the process asynchronous, we'll most likely make the terrain endless. So we'll be creating and destroying subchunks. And this new and delete, this new delete will be quite slow. And I think it would be best to separate the data outside of the subchunks. And so instead of new and delete, we'll be requesting this block of data. And this request will be waiting for a subchunk to free it up so that we can take it. This is my idea on how to move on from here. So that if we manage to do that, this waiting here will be gone. Not only that, but here when we start and move to the edge of the world, right now the world has an edge, here chunks will get generated, and that would be really cool. Here we'll have endless terrain. Right now there's an end to the terrain. That would be really cool if we have it. But that all depends if I can implement this new feature of having all this data separated from the subchunks. And I've done something like that before. Here I had what you call it, I had chunk data, chunk generator, where is it? Yeah, I had a vector of like references to chunk data, which they're on the heap, and the chunk data has the blocks and all kinds of mutexes, so it can create an order for like using it asynchronously with threads. You need mutexes. Yeah, and here I had all the opaque vertices, the transparent vertices, but this was when using just OpenGL. Now we're using Raylib, so here it will be like only the block data, but I would need to store the mesh and model as well. Yeah, here I had all the data, and here I had the connections of which, here I had chunks, not subchunks. And each chunk was connected to one of the data. And so when I create or remove a chunk, it had to go through this unordered map, and it had to check, is there an available data allocated I can use. If not, it will wait for one to free up. And so this way I avoided constantly doing new and delete. Let me think about it. Yeah, here I disconnect a chunk, and let me think about it. What direction are we going to take this project? That's what I'm wondering. We could not do that, since going in that route will is a direction I didn't even take with Java. With Java, the terrain was it wasn't endless. My Java world is not endless, and making the world not endless and not having to use threads simplified everything and made it easier to implement here all the cool features. That's the positive of not going to that route. And so I'm wondering, because here I'm in a crossroad. Here I have to decide, do I make the C++ world endless and use threads? Oh, come on. Do I make it endless by using threads? Or do I make it, or do I move on to implementing features like implementing the player, implementing ambient occlusion, foliage? Foliage will be very easy, and all the blocks will be very easy. But if it will be just like the Java clone if I go that route. But we've already done that here in Java, and it will be interesting how everything will change once we add the infinite terrain. Yeah, here in Java, the world is, it has an end. So here right now I'm at a crossroad. Do I keep my C++ world be like Java to have an end, so I can focus on foliage, ambient occlusion, the player movement. The player movement, or do I make the C++ world be endless? Do I make the C++ world be endless? If I do that, I'll have to work with threads. Let me think about it. I'm not sure. But if I'm going to do it, now it's the best time. Because if I start adding all these features here, it will make adding endless terrain more difficult afterwards. It's now that I have to decide it if I'm going to do it. Let me think about it. Let me think about it. Yeah, this is what we currently have. So what are the directions we can take this from here on? Because right now it's just like the Java Minecraft clone, even better. And we have a clean state. It's very clean right now. It's optimized. Everything is perfect. Do we focus now on adding foliage, trees, player movement, inventory, UI? Do we do that? Or do we try to make the world endless? So what is the overall goal? The goal is if we can implement as many features from Minecraft that we can. So like adding the nether, adding biomes, that would be cool. And when it comes time to implement biomes, I am not going to be able to do that since like the world has an end. And let me think about it. And with making this terrain endless, how difficult will it be actually? Because right now, what's stopping me from making this world endless, that's what I want. That's what I want. That's what would make me excited if we make it endless and asynchronous with separate threads. Since it's C++, it will not be that hard. So it would be very cool if we manage to do that. But I'm afraid it will be too difficult. But will it actually be difficult? What do I actually need? What will be the steps if I decide to go that route? Well, the first step would be to have somewhere data where I have where I allocate. When we start the game, I'll have to allocate for, like, I have the count of subchunks, 4,000. I'll have to allocate for 4,000 subchunks array with data, like for each subchunk. So for 4,000 subchunks, for each one of those, I'll need an array of 16 by 16 by 16 blocks size allocated beforehand. I'll need it allocated beforehand. I'll need it allocated beforehand. And then what else? Then I'll be creating the subchunks, and each one of the subchunks will connect here and connect with a block of data. And here it will disconnect, sure. Once it has connection, I'll have to call, let me think about it. Well, it will be asynchronous, so let's go to the main loop. And so here it will be using the thread pool, where I'll have to enqueue this function for generating blocks. And I cannot continue here. I cannot continue since the blocks haven't generated. Since the blocks haven't generated, so I'll need some kind of, I need to have like a subscription to an event, so when blocks have generated, to get a notification so that I can go over the subchunks and see if a subchunk can start generating mesh. And so I have to enqueue, I'll have to enqueue threads with this function to start generating meshes. And when a mesh has been generated, it can I can actually we can bring back this code here, so everything happens in one function, generating the whole model instead of just the mesh. We could do that. And so when the model has generated, so all of this will be in a separate thread. When model has generated, it will signal a flag that it has a generated model. So here when we request to draw, the subchunk will just, here in the draw, it will have a conditional to check, does it have a model to draw? If not, it will be skipped. And that's how when the game starts, yo, hello, what's up? And that's how when the game starts, all of these draw calls will be skipped, since no subchunk will be ready. None of the subchunks will be ready. And so that's how at the start everything will be empty, and slowly in a few seconds subchunks will start drawing, since here in the draw the conditional will start to signal, okay, we can actually draw now. We can actually draw now. And it will look something like that. And when the player moves, so in the while the main loop, we'll have to check if the player has moved from its subchunk to another subchunk. If that has happened, we will have to check the current, all the current subchunks we are in. We'll have to compare with all the new subchunks, and the difference to tell, we'll need to free up subchunks, which will, where are we? Which will call the destructor, which should free up subchunks, and here the creation will, yeah, when we move from our current subchunk to another, we'll first free up those ones that are not needed, and we'll connect with the freed up ones. And once that happens, we'll have to once again enqueue generation of blocks. We'll once again have to enqueue generation of blocks. and to subscribe to an event that notifies blocks have been generated so that we can check, can we generate the new model? It will be something like that if we decide to add threads, support of threads, if we decide to do that. And so now, right now, I'm at a crossroad. I have to decide, because now is the perfect time to do it if I am going to do it. Are we going to make the world endless and add threads to add trading? Or do I move on and leave the world be static like this and add foliage, trees, player movement, destruction of blocks, inventory, crafting? So basically like doing an exact copy of the Java clone. We'll basically catch up really fast to the Java Minecraft clone if we don't add threading and don't make the terrain endless. We'll be exactly where we are with the Java clone. So the main question is, if we decide to invest the resources, the time and energy to add threading and make the world endless, is that of value to us? Does that help us in any way? Does that make a difference? The main difference is when we come up here to the end, this will start generating. That's the main difference. That's the main difference. And the other difference is, for example, when we implement lighting, because right now there is lighting. Here, look at how there are shadows. The main difference is problems will become more difficult. It's more difficult to implement. Like, for example, let's say here I put a torch, and here it will light up what we have here. But when the terrain is endless, and I get to here, like this will generate, and if I haven't filled it up with the new light data from the torch, it will not be working. So features will be harder to implement. So is it worth it to make the terrain endless? Is it worth it? That's what I'm wondering. Is it worth it? Or the other question is, am I actually at a crossroad now? Is it that important to implement it now? Like, because I'm telling myself that implementing it later on will be a lot harder. Is that actually true? And my argument for that is because if I implement it now, I assume it will be easier since the code base is smaller. And for example, I don't have lighting, I don't have all these features. And so every other feature that I add will depend on the architecture. It's a big difference implementing lighting when you don't have threads, you don't have asynchronously running code. And that's my argument for why I assume it will be more difficult later on to implement multi-threading and endless terrain. The best approach would be to keep it as it is and just do the same to copy the Java Minecraft clone, this clone, and add foliage, add these, to add these item drops, to add the inventory, to add Steve, to add mobs. That would be the best approach since I've already done this, and once I catch up to the Java Minecraft clone. I can add even more things. I can add more mobs. And I can just keep it simpler for me, because the more I think about it, the more I'm convinced making it endless and adding threads will just make it more unnecessarily difficult for me. It will just make it unnecessarily more difficult for me, if I think about it. Because right now we can make a lot of progress if I don't add threads. If we don't add threads, the rest of this stream will have foliage, we'll have trees, we'll have maybe even ambient occlusion, we'll have maybe even lighting, maybe even the player with the Half-Life like movement. We'll have many things, maybe even collision, just in this stream. But if I decide to add threads and make it asynchronous, maybe in the best case scenario, at the end of the stream, we'll just have endless terrain. And when we open the game, the terrain will start loading instantly. We'll not have this wait time of like 6 seconds. Where is it? Will not have this wait time of 6 seconds. And there is a big chance even if we manage to do all of that, if we go with having threads, even if we manage to have endless terrain, oh, I think it crashed. Even if we manage to have endless terrain, that doesn't guarantee everything will be fine, because then we'll have another issue of like having chunks that haven't rendered. Because I have a Minecraft C++ clone with endless terrain, and there, some of the time, some chunks are not rendered. And so you get all of these weird bugs that you have to manage. And so the more I think about it, the more I think it would be best to not go in that route and to just do an exact copy of this Java Minecraft clone, but with all the improvements C++ has to offer. I think that would be best, because that way we're keeping it simple. Yeah, I'm almost convinced. I'm almost convinced. Yeah, that would be cool. And even about the loading, we can still make the loading happen. We can still make this annoying loading happen asynchronously with threads. We can still do that here. Instead of having this white screen, I think we can do it without having to do all those complicated things. I think we can do it. I think we can do it. So that will be the goal. So the next step will be, when we hit play, to not have to wait here with a blank screen, but to be instantly inside of the game and to look at the terrain generating in real time. That would be the coolest thing. Yeah, that would be enough. That would be enough. I don't need endless terrain as of now. I don't need endless terrain. And after we have that, I'll add foliage, I'll add trees, I'll add the other cool things. Yeah, that's what I'm thinking of doing. That's what I'm thinking of doing. Yeah, that will be the next step. Yeah, okay, so for these 2 hours, we made this terrain loading from 18 seconds, we made it down to 6 seconds. Now it's faster than Java. That's what we did in these 2 hours. Also, in these 2 hours, recently, we decided the direction we're going to take this project from here on out. That's what we did in these 2 hours. So for the rest of the time of this stream, I'll make this terrain generation happen on a separate thread because it will be a lot nicer, and maybe to prioritize to load the subchunks around us to start loading initially instead of, yeah. And then we'll move on to adding foliage, trees, and maybe the player moving around in the world. So collision. And to be able to remove and add blocks as well. If we manage to do that in this stream, that would be awesome. Yeah, so I need 2 minutes and I'll be back. Okay, I'm back. So let's make let's have terrain generation happen on a separate thread, and let's make it happen on a separate thread, and then let's start porting features from Java to here. That's what I want. That's what I want. Yeah, let's do that. That would be amazing if we manage to do it. Yeah, we already have here. We already have here we create a thread pool, and here we destroy it, so we can actually start using threads automatically. Where should we start using them? Here we create the subchunks. We add them as reference to the world, so we have global reference to them, and we ask to generate the blocks. So all of this needs to happen on a separate thread. And this needs to happen on a separate thread as well. We can actually think about it. Mesh template. What's this? It's the cube mesh template. Huh. Let me think about it. I need to clean it up a bit and organize it. This I don't need to give it here, this cube mesh template. Here I'm giving it since I'm reusing it. I'm giving it as reference. It would be best if I have like some kind of like global access to it. And how should that happen? in my Java world, I have a cube mesh pool. So that's what we're going to do. Cube mesh pool header and cube mesh pool CPP include cube mesh pool header, and here pragma once, and here cube mesh pool, and here everything will be static, I think. Yeah, let's look at the Java. In Java, yeah, that's where I let me think about it. Yeah, I don't have rotations. Let me think about it. I can make it even a class public, and here I could have structure cube mesh pool data, and here it will have all of its data since it will be static. Let me think about it. Cube mesh pool. Here I need static const static int max templates to be 30, let's say. That's what I used in the original. And so inside of the data, here I need include cube mesh template. Here I need cube mesh templates. I need an array. How many? Max templates. Like this. Here I need static cube mesh pool data, like this. This is all the templates. What else? I need a vector. So here subchunk, I need copy of this inside of here, and I need, I think, a clear function and a generate function. Template pool here. Let's look at what functions we actually have. I need static, let me think about it, cube mesh template reference get template. I need static void next template. I need static void generate. That needs int call basis. Then I need, we could also have support for textures. then that's it. That's it. Cube mesh pool. Cube mesh pool. Cube mesh off. Cube mesh pool. Pool. Cube mesh pool. Come on. Cube mesh pool. That's it. And so here I need also a current, needs to be integer current template. And so here we just increase it. Here to return templates current templates like that. And here when we generate let me think about it. When we generate, we want to clear. Oh, it's actually data this and data that. Data. And so here we need data positions clear. So we need to clear up the arrays, the normals, the UVs, the indices, and there should be another generate. Think about it. Yeah, current template. Yeah, here we need a for loop for int I equals 0, I less than current temp data, current template, I plus plus. And so we need data, current template, templates, I to generate. Oh, come on. Rename it. Get. Rename it. Next. Rename it. Generate. QMesh pool, sure. And here, what's the issue with templates? QMesh templates. Yeah. They should have this generate method. Oh, we probably need to have it here. Yeah. So here, generate, then curl faces, like this. And we need, let me think about it. We need maybe to do it like we do it here. Generate, like this. Template. I'm abstracting away how we generate blocks. and it will make it easier moving in a synchronous way, since everywhere will have access to it from Cube Mesh Pool. So Cube Mesh template, mesh template is data templates, and so here we do generate, and we go over the positions, normals, UV zeros, and indices. Fine, and then what's next? And current data, current template to be reset. That's it. That should be it. And so now in subchunk, I did all of that, so we don't need here a reference to mesh template. That was the reason. Generate mesh. And so here we want cube mesh pool. We need a reference to it. Cube mesh pool. Here we want cube mesh pool get template like this, cube mesh template reference like that, and mesh template set UVs. We do cube mesh pool next template, cube mesh pool generate, and here curl faces. We don't need this. And inside of here let me think about it. And inside of here we want positions to let me think about it. I want to combine these positions with the cube mesh pool ones. Let me think about it. Or let me think about it. How are we going to do that? I need these positions, which is a vector, to combine it, to add to it from the mesh pool from these positions. But they are here. We have only cube mesh pool has access to it. Only cube mesh pool has access to it. So, so do I give the cube mesh pool the vector and to have it to combine it here? And it will not be just one vector, it's a couple of them. It's 1, 2, 3, 4 vectors. It's 4 vectors. And if I add another one, like the colors, I'll have to make changes once more. So it's not that easy. It's not that easy. I have to think about it. Have to think about it. Have to think about it. Because in Java, the way I did it is I had direct access. I had direct access. So in Java, subchunk, here I get position. Yeah, here I just had direct access. Cube mesh pool and then dot textures. I had direct access. I could let me think about it. I can have a structure that is all of these. And if I make changes to need colors to make change to the structure that I'm passing along. Well, that structure is just the cube mesh pool data. It's just that. It is just that. I could have it. Yes, we can have it be defined here, or like here, or like here. It can be defined here, and to have static cube mesh pool data reference get data, and here to return data, and inside of main let me think about it. Here 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 we need cube mesh pool data reference. No, cube mesh pool data to be equal cube mesh pool data. No, cube mesh pool data get. Oh no, get data. Get data. And so now we have access and we can do. We need to combine them. So how to combine two vectors? CPP combine vectors. How to combine them? Pre-allocate memory. We could do this. We could do that. So here. So here. How to concatenate two vectors? So in positions, insert, and here to use positions end, then cube mesh pool data positions begin, and then here end, like that. And to do the same for the others, the normals, UV0 and indices, normals, and then UV0, and then indices, like that, like that. Now we should have the same result as before, and we can move on to adding threads without making the world endless. Are there any errors? Of course there are. What's the issue? Generate mesh. Tracy has issues. Tracy has issues. Here we remove this and let's stop Tracy. Tracy enable. Let's stop Tracy. Off. Here I need to include raylib h. And include vector and what else? Cube mesh pool data. Here it's cube mesh pool, like this. And here was the issue. Here was the issue. Data pushback. But here I need. God damn it. Here it's cube mesh pool get data. And here we have an issue. I need to give it an offset. I need to give it an offset. I can give it here. I can give it here. As a reference. And here include ray math. And here to have access to it. And here when I do it, to give local block position. And how is it? Yeah, it works. Nice. Nice. Now that it works, we can move here. We can call this function inside of here, generate mesh, and we can separate them with a scope, generate mesh, and another scope, upload mesh, upload mesh, and another scope, of load mesh, like that. And here inside of main, yeah, and we can enable the profiler here on, and let's reconnect to see, are we slower? Perfect. Let's look at Tracy. Generating all models about 6 seconds, and with this 6.5. But we're running the other Minecraft clone and streaming, so maybe that slowed it down very slightly, but it's all right. It's all right. And so how do we commit this? Add mesh template pool, which is a singleton, and we have global access to it. Now we did all of that so that we can finally add threads. We did all of that since generating the models was done in 2 steps. Now it's a single function. And here generating blocks is also a single function. And we don't need to give reference to like a cube mesh template. And so now let's try to use threads so that this loading, we don't have to wait for it. It can load the game instantly. That would be perfect. I want to be using threads. And how to do that? How to do that? How can we do that? In order to do that, we need to enqueue the function. We need to enqueue this and enqueue this. Let's enqueue just this. Just this. Because this part is very fast. If we comment it out, look at how fast it was. Yeah. We just need to run this in separate threads, the model generation. That's it. And so can we do thread pull enqueue, and here we need, where is the thread pool? We need Like something like this. This is a lambda function, I think. We need here like this, like that, like this. So here, can we do like this? And here we need references to these. Yeah. Will this work? There's an error. Breakpoint. What's the issue? Oh, it's doing a copy. Yeah, now it's not doing a copy when we pass it to the thread. Now, is it doing its work? Nothing is changing. Let's do let's add a grid. Let's add a grid. So here, draw grid. Like this. And if we start it, how did I have it before? Let me search it up. Minecraft. Yeah, what's up? I think if you are doing Raylib with an OpenGL backend, uploading a mesh from a different thread is not a good idea. If I'm going to do it from the main thread, I'll have to separate it from the function. But let me see. I want to first add the grid, so that when we don't have any subchunks, we can at least see what's happening before moving to Minecraft. And why is it lagging so much? Let me stop it actually. Oh yeah, it stopped. Yeah, so it's the GitHub issue. Where is the grid? I want to see the grid. I don't need to copy this. Yeah, browse files. And in source, main, I had a grid, this grid. I want to reuse it. Here. Want to reuse it. And we are looking around, but I'm not seeing the grid. Yeah, we're looking around, but I don't see the grid. At least that we should be. Oh yeah, because I'm drawing it in the wrong spot. Should be here. Because OpenGL is famously bad with multiple threads. Yeah, we'll organize it. We'll organize it. Let's just see if we are in game. Yeah, we're in game. Yeah, perfect. But the subchunks are not drawing. That's the issue. And you suggested that the main problem is since here the uploading of the mesh, it should be from the main thread. Yeah, we generated. Sure, that can happen in the separate thread. But this... Let's think about it. Generate model. Okay, we can move it from here. We can move it. Let's move it. Generating all meshes. Generate mesh. We remove this. We don't need this. And here, generate model. We'll remove this. Now here, this will not be happening in a thread, sure. But the issue is that now that this part is asynchronous, we have to wait for it. So we cannot do this. We can do it here when we draw. So generating mesh, we could have some kind of indication. Why is it still complaining about this? I thought we solved it. What if we restart it? Here. Now it should be gone. So here when we generate the mesh, should we have a boolean that's like mesh has been generated? Yeah, it still has. Okay, we'll have to address this at some point. It's probably because of the cube mesh pool. So let's have some kind of indication. Subchunk mesh. Here is the mesh actually, and by default it's zeros. So if we look at it, by default, mesh, yeah, by default, so vertex count should be 0, something like that. That's how we can check it if we are done with it. But not actually, since the thread can be like here, vertex count, and it's still not done with all of these. Let me think about it. How can we signal the main thread that we are done? And so when we draw, let me think about it. Well, let's do a naive approach. And we'll improve it later on. We'll have variables, booleans, mesh generated. We'll do a naive approach. Mesh generated. And once the thread is done and has generated the mesh, when we are attempting to draw, that's every frame, to check mesh generated. Since the mesh has generated, to have another boolean, model generated. To have another model. Yeah, to have another boolean. So generate, we're simplifying and we can improve later on. Here, let's do defaults like false and model false. Oh, to wait for all of them. That's a good idea, since this will still be an improvement, since I'm waiting all of the threads to finish. They're doing the job at the same time. But we will not. I prefer to have it to not do this. I prefer to not do it, since it will be a lot cooler, since we will be able to start the game and see in real time chunks generating. That's what I want the most, and I will not have that if I wait for all the threads to finish. Yeah, this shouldn't be that hard to do. Famous last words. So here, and it's okay if they're regular booleans and not atomic type, since only one thread will be actually writing to them, but multiple threads will be reading. Only one thread will be writing. Mesh generated. Here, where is it? Here, the mesh is generated, true. And so here where we attempt to draw, if mesh generated and model is not generated, if we are in this case, we need to generate model, and it will need a texture actually. Needs a text. It needs the texture, and I'm not a fan of having to pass it around. There's to solve this, I need to pass the texture here so we can create the model, but I don't want to pass it around every frame for every draw call, this texture. An alternative is to have some asset management class that we can just ask it for the terrain texture, but let's keep it simple. As of now, we can change it later. And here in the draw, let's have access to it. And in the main here, we'll give it here. We'll give access to it here. So every time we hit draw, if the mesh has generated, if the mesh is generated and we don't have a model, we generate the model. Now we can do it, and everything is running in the main thread, and that should be okay. Let's say, as of now. What else? Else, if we have mesh generated, and here we'll set this to true, model generate. Else, if mesh is generated and model is generated, we are here, just like before. That should be it. That should be enough for what we are doing right now. Now we should see subchunks starting to generate. The upload of the data is happening in the main thread. There shouldn't be an issue. Maybe we need to start the profiler. Yeah, what happens here? Model. We don't see an upload of the model. Oh. Here. Generate mesh. We think about it. Yeah, here we generate the mesh. We enqueue it. Are we missing something? Are we missing anything? Maybe we need to check with Tracy what's happening. Discard, reconnect. Let's check out Tracy. No, the uploading is happening when we attempt to draw. Yeah, I comment this out since this is happening asynchronously. And when we go here and we try to generate a model, the meshes are not ready. So what I do is every frame, when we attempt to draw, we check if mesh has generated but we don't have a model. And in that case, we generate a model where we upload the mesh. And so right now I want to see in Tracy what's actually happening. Where's Tracy? Here. Is Tracy doing anything actually? Oh, maybe it's offline Tracy. Maybe Tracy is offline. Tracy enable. That's the profiler. Yeah, it's on. What? It should at least have the main loop. It for sure should have the main loop. Let's stop the Java Minecraft clone. Yeah, that was really weird actually. What? Let's restart it. It should be... Yeah, right now we're running the game and it's connected to Tracy 100%. And it should be sending data to the profiler. Yeah, now it's sending data. Now it's sending data and here we have actually the separate threads. Yeah, this is the main thread. Generating the blocks. Yeah, I have this on the main thread since it doesn't take up that much. And here, what do we have here? Generating all meshes. What? Generating all meshes. Generate mesh. This is in a separate thread. Go through all blocks. Yeah, they're doing something here. Generate mesh. Generate mesh. Generate mesh. Yeah. And here. Generate mesh. Sure. Sure. Yeah, they're generating the meshes perfectly. And they do it how fast? They do it in 27 milliseconds. What? That's very fast. And here we are in the main loop, but we don't have we don't have model. The model code is not running at all. So yeah, let's look at let's debug it. Let's debug it. Not voxel engine sandbox, the draw command. Here. Mesh generated is false, and so we don't execute this. The thread has not set this to true, and I have it here to set it as true. And the thread is working with the reference to the subchunk. It should be setting its boolean. Yeah, that's the only issue. Can we look at the actual mesh? Can we look at the subchunk mesh? It's empty, the mesh. The mesh is empty. It should be filled up. So the work that the threads are doing is not affecting the actual... Is it like doing some kind of copies? That's really weird. Yeah, that's really weird. So a mutex mutex is needed for when multiple threads are doing work. Oh no, wait a minute, actually. As I think about it, as you said mutex, here it's actually going through neighboring subchunks. And maybe it's like, oh, I shouldn't draw a face, I shouldn't draw a face, and it's like returning here and not doing anything. But let me think about it. All the blocks, like the question is, do we need the mutex like you ask? Like, do we need to synchronize the work of all the threads? Well, in the main thread, we first generate all the blocks. This has happened before we start threads. We have generated all the blocks, and we are not, and from the threads, we're not writing anything to them. We don't write anything, we're just reading. We are just reading. But maybe we're not getting access to... Maybe we're not getting access to the neighboring sub... but that shouldn't be an issue. We would still be able to create a mesh. Yeah, we go over the neighbors. Yeah, we don't need to synchronize them with a mutex. We don't need that. Mesh preparation. Do we have mesh preparation? Actually, here we have generate mesh. Generate mesh. This is the function. And here we go through all the blocks. Go to block neighbors. And I'm not seeing anything about mesh. Find. Ignore case. Find. Oh, okay. Now that we ignore case, do we have model? No. Okay, mesh. Find. What has it found? What has it found? Oh, not this. Generate mesh, sure, but I'm looking for... What do you call it? Mesh preparation, that's what I'm looking for. If we are not here, that's an issue. Find. It cannot find mesh preparation. Why would that be? The engine sandbox here. The only way that happens if there are no indices, which is empty, no vertices generated. And that would happen if this is empty and the cube mesh. Oh male. This is the problem. This part of the code, if it runs on a single thread, there is no issue. If it's multiple threads, we may need a mutex. Since here, this abstraction helps me to create all kinds of blocks. And this is a cube mesh pool. So one thread is requesting here a template. And I've done an optimization here when it was in the main thread. I could reuse these classes. But since we're running it asynchronously, this reusing of it now has problems. Yeah. Yeah, mistake so bad. I spoke Bulgarian. Yeah. Mistake is that bad. Is that bad of a mistake? Uh, hmm. Let me think about it. The easiest thing we could do is here, inside of the pool, where I have where I have these templates, here to have a mutex. Here to have a mutex, and when I request a template, to be able to lock and unlock the pool. That's one thing I could do. Let me think about it. Or I could have, or when oh god damn it, I got an idea when I request a template to only lock it when I'm out of templates. So I could increase to have more templates, and every thread to request a cube mesh template. But the issue with that is that all the data gets stored inside of the pool, inside of here. It gets stored here. So if I want to do something like that, I would have to do more cube mesh pools so that more threads can use. We could, let's do the simplest thing we could do. The simplest thing would be here to have a mutex and to the threads to wait for their turn. Where is it? They'll have to wait their turn. Here, how did I use mutexes? I've used them before inside of here. In the generator, no, in the data, chunk data. Yeah, I'll have to use these mutexes to lock and unlock them. There's no other way. Where is it? Here, I need to have mutex to lock and unlock it. Now do it, I'll just need 2 minutes and I'll be back. Yeah, I'm back. Now let's use this mutex. Let's use the mutex and let's see how I've used it before. How to actually lock and unlock. Because I've forgotten. It shouldn't be that difficult. Find all references. Here. Should be this. And so, let me think about it. Subchunk here. Let me think about it. What's your problem here? It is a deleted function. I haven't deleted it. I need to lock and unlock the mutex, but how will I do that? How will I do that? Cube mesh pool. Maybe I have to do it from here. Current template is initialized. Okay, no problem. I'll initialize it to 0. Yeah, I need to somehow interact with this lock. I need to interact with this lock, but where? Static void request access, like this. And here to data lock, like this. And in subchunk, generate mesh here, cube mesh pool request access, and here get data. What's the issue? It's not deleted. It is a deleted function. No, it's not. No, it's not. It's right there. It's not deleted. What's your problem? Get data returns the data. What's the issue? Get data, cube mesh, pull data. That's it. Get data. Yeah, it will figure it out. Okay, it continues with that error. Attempting to reference deleted function. That doesn't make any sense. Cube mesh pull date. Okay, let's look at the git difference. Yeah, here I just add a function. Here, yeah, nothing that, but yeah, here requesting access. And here in the main, enqueue generating the mesh, and I request to draw. Not here. I request access, mesh generated. Sure, and here the draw. Yeah, so why is it complaining? Maybe these brackets are wrong. No, the brackets are all right. Why is it complaining? Cube mesh pool data, cube mesh pool data, cube mesh pool request access, get template, next template, here get data. And get data, cube mesh pool, get data, return data. Like, so why are you complaining now? we don't have. It is a deleted. No, it's not. Okay, let's do CMake lists. Let's update that. And now let's see. It's still complaining. Let's delete the build and generate everything cleanly. And I'll restart Visual Studio. And start it again. Where is the main here? Target is missing, then generate it. Yeah, it's still the same issue. Attempting to reference a deleted function. It's not deleted. Man, what's your issue, man? Sometimes C++ just is so difficult to work with. And most likely it's on my part, the issue. And here the warning of having too much data in the stack is gone. Okay, here I request access, which locks the mutex. It locks the mutex. Okay, now I get back that error. Oh no, I don't get it back. This is the most difficult part. Okay, let's do it like this. Cube, mesh, pull, get data. Here it is, get data. It is a deleted function. C++, it is a deleted function. Default definition will be ill form initialized non-static const member. The default constructor has been deleted implicitly because the class contains non-static calls. Oh, I get it. I get it. It contains something that is not static. What? Everything is static here. Everything is static. Cube mesh pull. Everything is static. Where's the data actually? Here's the data and the data is static. No, and even if we look at the git commits, qmesh pull, I only add this function to request access. Qmesh pull, and that function is static. There's no issue. Maybe if I remove this, is it solved? It's still the same. Since is constant, it must be initialized, but the default constructor wouldn't normally initialize it. Therefore, to get the default constructor, you need to define one yourself. Huh. Delete. Deleted function. Oh, this equals delete, but I haven't done this anywhere. A deleted function. No, I haven't. C++ singleton class deleted function. And it's only this function, get data. It's only that function. Everything else working fine. Cube mesh pull data. Get data, return data. What the fuck, man? And this is so annoying. And I am not sure where to go from here. Yeah, this was before there wasn't an issue. Oh, I get it. Because I added this mutex. Yeah. Probably I need to... Where is the chunk data? This mutex. I need to include it. it will not tell me please include mutex, this file. Please include this file. It's telling me this function is deleted. Like, fix up your errors, man. Now let's compile it. Still the same error. Surprising that it worked before. If we comment this out, go here and delete this and delete this. Now we're back like before. Is it solved? No. And if we delete, where is it? Where is the data? And if we delete this, was this the problem? Yes, that was the problem. That was the problem. So here, just because I added this mutex lock, I need to initialize it. Do I usually do that? Here, do I initialize this? Final references. No, I don't. Yeah, I just lock it. Let's see what else do I import. Mutex. That's it. Request access. Like this. Yeah, what's the issue? And just doing that, subchunk says this is deleted. So changing the data to have this mutex lock. Okay, let's look up mutexes. How can we initialize it? Mutex. Not access directly, sure. Constructor. How to initialize it? Here he has the mutex. Sure. And he just uses it. Like, why is it complaining? Why is it complaining? It's initialized. Come on, man. Data lock. Maybe I need to change the name. Mesh pool access. Yeah, just change the name. And to initialize it. But come on, man, work with me. Let's see how others use it. Yeah, I created. Create object. Lock and unlock. Huh. This makes no sense. Here. Yeah, here, std mutex, all the mutexes. I don't have a constructor. And here it's not complaining, no issues. Chunk data, no issues. And why is it complaining for me? Request access. The only issue now, it's here, it says it's deleted function. So this function is deleted. Okay, so we'll just make a getter. We'll just get getter. Get access. And here get access. Oh, what's your issue? Ah, void. And here to return this. And here where I'm using it, maybe there was another issue. Maybe the actual issue was here when you actually lock or unlock it, you would have to include... No, that's it. Okay, let me do this. And subchunk here, cube mesh pool, get access, like this. Still the same problem. Get data returns the data. And it's telling me this is deleted, but it's not. And it's deleted because the structure has this. And here it's complaining the mutex is initialized. It's not initialized. And everywhere I look, nobody initializes it. Let me think about it. What's your issue, man? Current templates. Let me think about it. Okay, do you want a constructor? Current template is 0. Structure cube mesh pool. Like, what are you on about? Man, this is the most annoying part. We could make it outside of here. We could make it outside of here. And have it here. And have it here. Like this. Like that. And now what's the issue? Mutex, Q mesh pool access. Yeah, mutex. Maybe it cannot be static. Maybe that's the issue. God damn it, man, this is so annoying. Can it be const? And here data. The return to make God damn it. It has to be like this. Has to be like that. And here in main, no, subchunk. And here it has to be not constant. And sometimes C++ is so annoying, man. All of this struggle here is because of my lack of C++ knowledge. This get data is complaints. When I try to use it, it says it's deleted. CPP function deleted, but it's not. Yeah, I'm not doing this equals delete. Delete it. Come on, man. There is something else we can do. We can separate this because this is all we need to send. I could separate it in another structure and return that. Yeah, but like it just makes the code messy, so it's unnecessary. Get data returns reference to cube mesh pool data. And this is the only function deleted because and the difference from this function and all of this is it returns access to this. Maybe if I make it const. Const. Maybe if I make it constant. Subchunk. Are you still complaining? It's a deleted function. No. It still complains. It still complains. What if I make it const? And now it works. Oh. Was it making a copy before? And it's not allowing me to do that since there's a mutex there? Man, that's crazy. We can finally start it. Nothing is happening. Nothing is happening. Is the lock actually doing its work? And I don't get upload of a mesh. Let's do raylib trace. Raylib like log. Just logging. Where is it? cheat sheet, logging. Let's log something. And let's log let's log level info, log info, requesting full access. And let's see what happens. Requesting full access, requesting full access, requesting full access. Look at how many requests. And the requests stop. This should organize them, the threads. This should organize the threads. Get access. This gets a reference. We could do it here. This thing. Here. Request access. And here. Void. And here. This. This. Request access. Void. This. And then in subchunk here cube mesh pull request access. Is it the same? Should be. Should be. What can we do? We could do profile scope, going through all blocks. Here, can we put this here? This request, let's put it here, and here prepare mesh template, and here mesh template. Let me think about it. Here actually. And here let's do profile function, and we'll have to use Tracy. Let's use Tracy. Reconnect, start, and let's see what's going on inside of Tracy. Do we get... No, let's do something else. Let's do something else. Let's do discard, reconnect. Let's check request access profile function, and we'll look for it. We'll look for it. Here, Tracy. And let's look for it. We found matches. Now, here. Huh. Group by thread. Zone name, call stack, parent. This is by threads. By order, by time. Lock. Let me think about it. So what are we looking at? Here in this region. I want them highlighted here. Let's stop it. This region. I want to just look through this region. What's this? Static thread dynamic. Zone name shortening. No, I don't need this. Messages. Statistics. Request access. No. Flame. What's flame? No. I don't need this. Memory, compare, info. How can I make it to show just one function? Tracy, show just one function. I want to untoggle the other ones. Damn it. Let's look at here. So going through all blocks, go through neighbors, request access, prepare mesh template, generate, then go through all blocks, current block neighbors, request access, prepare mesh. So for every block, every thread, they have to request access. That would be annoying. Let's look at when a couple of them are working at the same time. Do they actually wait for each other? That's what I'm looking. Are they waiting for each other? Where is the last request access? Here. Limit. No. So here I request access. And here is the last. No. Here is. What is the last request? So here we are requesting access. Oh, it's doing nothing. Do you know why? It's doing nothing, the lock. And because this lock is for the scope it is in, I think, here. And it's only going here, it's locking, and goodbye. Oh my god. Let's bring it how it was before. We need to change it. Here, we need to change it to return this. Get access. Get access. Here, get access. Mutex reference. And then inside of subchunk, get access, and here we need to do that lock. Here we need to do it. This thing. Yeah. I forgot about that. We get access. And for how long do we need this lock? For how long? Let's scope it out. We need it up until here. Up until here. And so profile scope. Lock mesh template pull. Yeah, now it should do it. It's not doing it. Fuck. We need to profile to see what's going on. But that should be it, actually. That should really be it. Let's reset Tracy. Reconnect. And start again. Tracy. Here. Lock mesh template. And it's not locking it since here lock. Oh, or maybe it is locking it and it's taking so much time since it's waiting. And how long was this increased to? All of this waiting. Huh. Lock mesh template pool. Let's look at the execution. So here we have this function. Where is it called first? Here. And here, look at this lock, how fast it is. And here it gets access. But here, this lock, here it waits, gets access, prepare mesh template, generate. And why is it not releasing it? Oh, fuck. So here... I'm... Get access. Get template. Okay, let's look at... Let's profile get template. Let's profile this. Let's profile this. And let's profile generate. Oh, I have generate. And then pull. And I'm locking it for how long? Up to here. Let's do profile scope here. This should be, what should we call it? Copy over mesh pool data. Like this. And I need to reset it. The trace. Reconnect. Start. Tracy. And what's up? Go through current block neighbors. Then we lock. Where is the first lock? Where is the first lock? Here. Here is the first lock. Here is the first lock. No, here is the first lock. We get the mutex. And here we get the mutex as well. And here we have get template. We have prepare mesh template. We have generate. We have copy over the data. And we go through current block neighbors. We lock it. And we reuse it. Then again, reuse it. Yeah, this lock. And the other thread is still locked. Oh my god. No, this approach is bad. This is a bad approach. A very bad approach. And all of this was just so we can have instant loading. Okay, we use this cube mesh template. We could have a pool for each subchunk. Each subchunk to have its own pool. And that would solve the issue. Yeah. That will solve it. Yeah. That will solve it. But we can do a commit. Attempt to synchronize mesh pool data usage. I'll be right back, 2 minutes. As I was gone, I thought about it, giving every subchunk mesh pool, cube mesh pool. I thought about it, and that would be 4,000 mesh pools. And each mesh pool has If we give each sub chunk a cube mesh pool, that would be 4,000 mesh pools, and that would be 4,000 times 30 cube mesh templates, and that would be all of these would be like this would be 4,000. Oh man. Let me think about it. I need this because it simplifies the creation of blocks. Let me think about it actually. Or we could have this to not be here, but to reuse the subchunk, because the subchunk has it. The subchunk has here. The subchunk has this. And I could just put it in a structure and give it to the when I so I can have like a mesh pool just for my subchunk. I could have a mesh pool just for the subchunk. Where is it? I could have it just for the subchunk, and I can have the next template, etc. Get template. Yeah, each to go through each template, and each template would have these. These are a lot of vectors multiplied by 30 and by 4,000. That would be a lot. Or I could have each thread to have so I could have just 4 pools because there are 4 threads. How many threads? There are 1, 2, 3, 4. There are 4 threads. There are 4 threads. I just need 4 cube mesh pools. Huh. Yeah, I just need 4. God damn it. Oh, was this worth it, man? Was this worth it? So instead of this being global and static, to instantiate it, to have 4 of them, or when I request template, just to have more templates. And yeah, but I need these. Let me think about it. God damn it. This is really annoying. Thread number 1 needs its own mesh pool. Thread number 2 needs its own mesh pool. Thread number 3 needs its own mesh pool. God damn it. That's really annoying. So one thread is at the start of this function. So here I could request a cube mesh pool. 1 out of 4. I could request it here. and I could have a semaphore that monitors the requests. It should be something like that, cube mesh pool. Should be something like that. So to remove this, and so here, and so here to have to think about it. Think about it. So I would need I can do it as I could have like a couple of cube mesh pool datas structures, a couple of these, and I could have a couple of these and a couple of these, like 4, for example, since I have 4 threads, I could have 4 of these, and I could have a function to request an ID. Yeah, but that would be asynchronous. And yeah, let me look at semaphores. Semaphores. Thread. Acquire and release. But can I get that counter? Here in the thread, acquire and then release. Sure. And where is the semaphore? Here, max processing slots is 3. Yeah, counting semaphore. Acquire. Sure. And what's the issue? Well, I could have access to the semaphore to be like acquire. Sure. And it will, and when I'm doing that, to request from here, yo, what's up? Lumi, C++, what's your question? So I could have a semaphore, and when I'm in the subchunk here, generate mesh, I could acquire the semaphore. So in the cube mesh pool to receive in some way one of these. Like I would like to receive an ID, like 0 for example, and to have an array of these and to get an ID. But but what if they're asynchronous? So 4 threads could call the function at the same time. And so one of them, like the only thing the semaphore is if to stop them from, to limit them after 4 to not be able to continue. I could have a mutex just for like handling the ID, or I could make the ID an atomic. like I could lock with the mutex the handling of the IDs. So here in the sub chunk, I would request an ID, and here and the semaphore here will either lock or allow me to continue. And here, once I've continued, I'll be like, when working with the template, I'll have to give an ID so it knows with which one I'm working with. And once I'm done, I'll release. But if the ID 2 is done, yeah, I would have a queue of IDs, of available IDs, and a queue of taken IDs. And once an ID is freed, to move it from one queue to the other, should it be a queue? Man, and this is just, all of this thinking is just for the generating the mesh. Adding threads complicated everything so much more. Unnecessarily. I could simplify it and have only one cube mesh pool, even though it will not increase the speed, it would still have the effect I'm looking for. Yeah, that's what I'll do. Cube mesh pool, so I'll bring back the mutex. Yeah, I'll bring it back. Like this, and where here I'll put a lock at the beginning. Here I'll put a lock, and I'll remove this lock. I'll remove this. And this should be it. It's not... Let's see now. Let's do let's output to the console max indices. So lock text lock. How to lock? Trace lock. Debug lock. What do I have available? Log debug and max indices plus max indices. I don't have it. Why? Maybe it's generating. I'll put it as info log info. Yeah, max indices, but it's not telling me how much they are. Max indices. Format, text format. Here, max indices, integer. 0. 0 max indices. 0 max indices. Yeah. Why is that? 0 max indices. We can also log here. Request log. And here relog. Let's see if the mutex is working. Let's see now. Here, request, free. Request free. Yeah, I think it's working. The lock is working. Sure. The lock should be working. This is the easiest thing we can do. Next, we are locking it. So we're doing one at a time mesh generation. And so we are getting the subchunk. We go through all the blocks. Go through current block neighbors. Let's remove this. And prepare mesh template. Here when we get data, here current face, let's output this. Current face I mesh template current face. Zero. It should be 1. It should be 1. It should be 1. Yeah, next template. So the thread is getting a template. It's preparing it, setting QVs. It increases current template, and we hit generate. Oh, after generate, current template is 0. What about current face? Current face. It's not reset. Here, here current face is 0. So the block is not generated. And that's okay for some blocks. That's okay for some blocks. So let's do log info here, and let's do yeah, let's just execute it. Here we should see, if we don't see anything on the console. Yo, we have chat. How's it going? The same as when you left, if you have not been here. We're at the same spot. That's C++ for you. Yeah, so the issue right now is, what's the current situation? I'm trying to generate the mesh in a separate thread, and so when I hit generate mesh, I lock the entire function. I lock it, and so one thread at a time generates meshes. This will not speed up, this will not give improvements in terms of speed, but it will give the result of where it starts instantly, and we can look at the terrain generating. It will give us that, and that's enough for me. That's what I wanted. That was the goal. And doing it like this simplified it, where this was giving me issues. Now it shouldn't be giving me, it shouldn't give me issues now. But what is currently happening when I debugged it is it always stops here. And this stop happens when we attempt to generate mesh for one block. It happens when no face has been generated, because here, if we go here, and if we go here, like we go over, for each block, we go over all the sides, and we decide if we should generate a face. And what has happened, it has not generated anything. But actually, we can test that even to be absolutely certain that that's what's happening. We can go inside of the generate, and here there should be at least one top face generating, at least one, and generating top face. This is too long. I suggest running with a debugger. In my experience, it's way more helpful than print debugging. Running with debugger. But what I'm debugging is happening in separate threads. Is it possible to run debugger in one of the threads? We'll see about. Let's see this trace log, if it shows up. Let's see if that shows up. And if not, we'll see separate debugging. No, it doesn't happen. Yeah, this was enough of information. We are not reaching here, ever. Ever. What about, are we reaching here? Generating. This is important. Yeah. Yeah, I need to be right back. There's somebody at the door. Yeah, I'm back. I'll see about the debugging. Yeah, but we're getting up to here. That was important. So we're getting to here. And curl faces. Let's see curl faces. We'll see this curl faces. Yes. 63. Yeah, I'll need to look it up in binary. Decimal to binary. 63. To curl all sides. It requests me to curl all the sides. And this happens all the time. So we are culling everything. And why is that? We are culling everything. Generate. Thread pool. Here. Curl faces. Here. Subchunk. Curl faces. Yes. Get neighbor block data. Get neighbor block data. And get neighbor block data. Here. And okay, can we debug? Even though we're running on multiple threads, yeah, we can debug. So can we go here? And is there a case where we actually are here? Is there a case? Yes. What about here? Yes. What about here? No. Wait a minute. Yeah. And there are cases where we're here. So the issue is that this is 63. So it's saying here this function every time returns true. So every time the neighbor block data, every time it's returning 1 every time. Every time is doing that. So okay. Let's actually look at let's stop here. Let's look at neighbor subchunks. What do we have there? Second, yeah, we have the blocks. And what about our blocks? Where are our blocks? Blocks. Where blocks? Outs. I want blocks. No. Watch. Blocks. Yeah, here. Blocks. This. I want to see the whole array. want to see the whole array. God damn it. Let me go through these. Neighbor type is 1, 1, 1, 1, 1. Yeah, every time neighbor type is 1, and that's a mistake. Local block position, this for 0, 0. Where's the issue? We have access to neighboring subchunks. Yeah, we have access. It's perfect. We have access. Why is it so annoying? Where's the issue? We are locking it. This is happening in a separate thread. And that thread has access like to this subchunk. It's calling this generate mesh. And inside of it, we get from the world, we get access to we get access here to the subchunks, which is an unordered map, and we find the subchunk we are looking for. It's just a pointer to it. There shouldn't be a difference when this is running in a separate thread. Then we go over the current block type. Okay, here. Is there a case where current block type is like R? There should be a case like that. Yeah, and there is a case like that because here we have a continue and we have reached here. Okay, curl faces. Is there a case where curl faces here condition if it's different than 63? Is it 63 all the time? It's 63 all the time, I think. Yeah. It's 63 all the time. That's a mistake. It shouldn't be like that. So every time, and it's 63 all the time if every time the neighbor is solid. Every time the neighbor is solid, every time the neighbor is solid. And why is the neighbor every time solid? Well, here, when it's 1. Here, here we have reached here. And we have points when we're here, and we have points when we're here. Let's have it here, check. If there is some point where this is equal to 0. Is there a case like that? Cannot be set. Has side effects. Okay, because it calls the function maybe. Okay, we can do it like this. Int block to be this. And to return it. And here the same int block, so we can debug it. And here to check, is there a case where block equals 0? No. No. And one more time. Is there a case here when it's 0? equals 0. Yeah. No. And it lags a lot because of the debugging. And it's done. That's the issue we are having using threads. Using threads, there isn't a case where here, and why is it like that? And this should be reference. This should be reference. What's the issue? Vector 3. Should be reference. Right? Oh, come on, man. I really wanted this. Let's bring it like before. Now let me think about it. So what about position to index? No, it shouldn't be an issue when we are running separately. Every time it returns 1. There isn't a case when we run this asynchronously. What if we bring it back like it was before? So here to not enqueue. Now it should work. Now it should work. Yeah, now it works. Yeah, this is what I wanted. This is it. This is what I wanted. What's the difference? Generate mesh, I enqueue it, and inside of it, I lock it. Let's look at the Tracy once more. Discard, reconnect, run. Tracy. And here, look at it. Generate mesh. Here it goes through all blocks separately. Then here it goes through all blocks. Then here it goes through all blocks. Generate mesh. What does it do here? Get access. Go through all blocks. Get access. Go through all blocks. Huh. So yeah, it happens here, 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 and here. Go through all blocks. What about here? Then here. Then here. They wait each other. Which will slow down, like it will. I'm using Tracy. Tracy is a profiler for C++. This is Tracy profiler. How much time does this take? About... yeah, it's still fast. Still fast. Oh, it's fast because it doesn't have much to do. Most of the ifs are like you don't have anything to do. Yeah, but the traits wait each other. Then what's the issue? This lock looks like it's working. The issue is that here, when I get the neighbor type, it says every time it's solid. But that's not true, since they are blocks. The actual data, the reality is that they are blocks which are air. When we get the neighbor block type, when we get the neighboring block, when we run this exact code on the main thread, there is no issue. Everything runs perfectly. When we are running it in a separate thread, this function here, when it has to return the neighbor type, it always returns 1 when it's running on a separate thread. That's the problem. These blocks is the current sub chunk blocks. It's an array on the heap. And here, so what's the is it problem with the index we're looking for? Let's look at this. Int index equals this, and here int index equals this. Let's look if the problem is with the index. And here is the simple case. Let's debug. Index 16 256. Yeah, and the index is always different. It's not a problem with the index. 0 5 12 2 5 7. Yeah, it's not the index. And the blocks, how can I look up the blocks? CPP, Visual Studio, debug heap array data. I want to inspect it. Via pointer. Let me do this. I want to inspect blocks plus this. Okay, perfect. So it's how big is it? It's 16 times 16 times 16. It's this much. What's the data of the blocks? Only once. And there are some other values, I think. And we have some weird, very weird values. Why? We have some zeros actually, and we have some weird values in the data. Okay, what if we do this when it's on the main? So when we comment this out, What's the difference? Is there a difference? It's pretty much the same. Yeah, it's pretty much the same. Yeah. It's pretty much the same. God damn it. We can check for here like we did before. If blocks, if block equals is different than 1 and run it. Now we have to wait it. The debugger slowed down this step a lot. Man, so disappointing. This is called too many times and it's slowing it down. Oh, we can test before this. Here in subchunk, if this culling is, if it's different than 63. And that should be the case for sure. Again, it's like very slow with this conditional breakpoint. We could output it to the console instead, but oh, you know what? No. I got it. There's something else we can do. We can simplify it a lot. Here we can simplify it. In main, here we can do only one subchunk. And there it is. And now let's put it in a separate thread. Like this. What? Did it actually work? It worked. So let's do 2 subchunks. So this will be 2 threads working together. The other one is missing. Huh. What about 3 subchunks? That's weird. If we remove the threads, yeah, it should be like this. Okay, what if we bring them back again? It's the same issue. It just renders one subchunk. Yo, hello, plus channel 2, what's up? How can I separate mesh generation in a separate thread? Here, maybe it's with the lock, the issue. Yeah, here we just have two subchunks. When I remove the threads, it works perfectly. When I put them in... Oh, maybe the iterator. Yeah. Maybe that's it. Maybe the iterator. Let me think about it. Generate mesh. Huh. Oh, can we... No. Can we do... no, we can do subchunk like this. Equals second. We can do it like this. What's your issue? Oh no, it's like this. And here to do it like this. Yeah. Maybe this small change will make a difference. No, it's the same. I only get one mesh. I only get one mesh. So every thread has reference to the subchunk, and I'm going here. No, all the blocks are generated. All the blocks are generated. We have somewhere ones, we have somewhere zeros. And that's happening on the main thread. That's not the issue. Here, I'm running all the threads, and they start here and have this lock. Let's look up mutex CPP. Guard. Where is this? This. So here, fake content. What's the issue? Join. Yeah, here I wait. Here he waits the threads. Here he starts the threads. And what do? They fill up here with URLs, the result. So they wait each other for working with this map, sure. They hit this guard, log guard. One mesh, yeah, not two or anything, I assume. Maybe it's not rendered properly. No, it's not the rendering issue. If it's like... No, yeah, I could look up what exactly is the issue. No, the issue was that here everything gets culled. That was the issue. Like, that was the issue. Because I'm trying to generate a block. When I'm generating a block, I give it information of the neighbors, and every time it's giving it that it should cull all the faces of the block. And that's not... When it's everything on the main thread, that doesn't happen. And the difference is here when getting the neighbor type, it's always a solid. It's always a solid. And I determine the neighbor block type by giving it local block position, which in a separate thread, that's not an issue. The normal in a separate thread, that's not an issue. Neighbor subchunks. This is just an unordered map where I get reference to the neighboring subchunks, which their reference is the same. Right? Right. Like I've debugged it. I had put debug points and I see that neighbor subchunks, this unordered map, has reference to actual subchunks, and each one of them has actual data. Each one of them has data, so this should be fine. And I give it to this function, so all of these should be fine. And here, this code, whether it's run on the main thread or separate threads, shouldn't be an issue. We're just reading. We're not writing anywhere. We're not writing anywhere. I'm not pro C++. There are multiple issues when you first use it. I hope that you get better over time, I guess. Well, I don't want it to be over time. I want it to be now. Because this problem is blocking me from continuing. I press run and I only get one subchunk. But before I didn't even have this. Before even this was empty. Let's increase here the height to 10. Yeah, now I don't have anything when I increase the amount. What if I put here 1? No. Let me think about it. Yeah, when I change, yeah, if it's just 1, I think it will work. Yeah, if it's just 1, it works. So I think, okay, changing these values breaks the game. Okay, so what does happen when we change them? This creates all the subchunks. If it's only one subchunk, what's the difference? Well, here it's only one, and we generate its blocks. And here, when we generate the mesh, here all of these, the difference is that when it's only one subchunk in the whole world, all of these will be null pointers. And so it will go when looking for the neighbor. When looking for the neighbor and it wants and it requests and when it skips here and it's requesting here a neighboring subchunk, it's always a null pointer. So it skips this. It returns 1. And this code, the difference is maybe that main. What if I limit it to only one thread? Because I'm using a thread pool. Where is it? Here, only one thread. Yeah, it works, but let's increase them to 2 subchunks. Still the same, but we can look at Tracy. Let's look at Tracy, discard, reconnect, and see the execution. Yo, why did you choose to store the neighboring chunks in an unordered map? Because let me see. Because here I need to give them to the get neighbor block function. Here I need to give them. If they're not in an unordered map, they will be in separate variables. And here I'll have to give 6 variables as reference. That's the only difference. That's the only difference. Let's look at Tracy. And here, look at how we have only one separate thread. Yes. And so we don't need even the lock when doing it like this. So there will be no asynchronous issues. No issues. So here, yeah, here we go through all of it, generate it. How much time does this take? About 6 seconds. Got to go study now. Good luck with the multi-threading. Thank you. I'll need this luck, man. It's so annoying. It's so annoying. What's the issue? What's the issue? Yo. Hello, what's up? If I remove that, look at the situation. If I remove the threads, I should see 2 subchunks. Let's start it. And there they are, 2 subchunks. Look at it. They're beautiful. 2 subchunks. If I start the thread pool, if I do the mesh generation in the thread pool, now I get only 1 subchunk. But if I increase the subchunks to even more, if I increase them, there will be 0 subchunks. There will be 0 if, like, I increase the height to 10. 0 subchunks. 0 subchunks. Come on, man. Why? Why? Generate mesh. The difference is, what's the difference? It goes through here without a problem, and it goes over every block without a problem, no matter if it's a separate thread, sure. But here, I have an integer that I pack data where I store in this integer 6 booleans, whether the neighbor is air or solid. And every time this curl face integer is 63, which means that every neighbor is solid. Every neighbor is solid. And so it reaches here, and because every neighbor is solid and nothing has been generated, we move on. We move on. Okay, we can, let's make it so only, what if we say every time all the neighbors are air? What? Is the same? Really? 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 Wait, that's confusing. That's very confusing. Is it reaching here? It should be reaching here. It's not reaching here. Huh. Why? Is it reaching here? No. Why? Is it reaching here? Yes. Let's remove the lock. We don't need the lock. Let's remove it. We don't need it. Does it reach here? What are the plans for your remake? What do you want to add in the future? I want to add the nether. That's something I want. Here all the blocks are air. Let's go back to the main here. Let's do the same code on just on the main thread. Just on the main thread. Yeah, it should be something like this, which like if I do like here 20, here like 20. No, if I do like here how much? 5 and here 1. Yeah, it should be this. This. It should be this. It should be this. And when I run it on a separate thread, let me run it again. I get problems. I get problems if I bring back the lock. Yes. That's weird. Then again, problems. Yeah, I'll be right back. I need 2 minutes. Yo, I'm back. Let's see what the issue is. Yeah, but this stream, the whole of it was, in my opinion, a big failure. It was a big failure, this stream. If I had stopped the stream at 2 hours, I would have been at a better place. So instead, maybe in the future, to start a stream, to work on something, and once I get at a good spot, like when we improved the loading time of the chunks from 18 seconds to 7 to even 6 seconds, to have stopped the stream and to have stopped it there and to have decided from there where to go, because we spent some time thinking at what direction to go, and to have spent some time on since I've taken the direction of trying to make this loud without waiting, to have done some tests off stream and maybe some reading up on working with threads, the basics of it, some preparations off stream, and then to start the stream and to have this failure be on a separate stream, because right now this failure and struggling with the threads and mutexes, this is ruining the initial good start of the stream. It's ruining it. What it looks like is let's see now. I'm running. What am I running? I'm running this in a separate thread, generating the mesh. And here, the only thing I'm doing here is these things. And here the mesh preparation, where I allocate memory. What if I allocate the memory and prepare the mesh beforehand? What if I do that? Damn it. Man, this stream was a big failure. Here it has now it's giving me these errors. Let's try it again without the synchronous way. Yeah, it works. And let's bring it back. Let's bring it back and let's see here the call stack. Generate model. Generate model. And it's called here Mesh generated and model is not generated. Here I attempt to generate the model. Subchunk mesh. It has 56,000 vertices. Indices. Triangle count. So it's 18,000 times this is triangles, so each triangle is three indices. Should be enough room for it. And here upload mesh is complaining VBO ID is null pointer. This is null pointer. VBO ID. VBO ID. For which one? For vertices. Mesh VBO ID. And where is this setup? Memory allocation. Raylib multi-threading. Maybe we're limited and shouldn't use threads with Raylib. Maybe. I'm allocating the memory in a separate thread. Man, why does it need to be so complicated? Here it's complaining of the mesh. Something is wrong with the mesh. Can we extract this elsewhere? But if I did that, I would need all of this data. This probably needs to be allocated beforehand. Let's attempt to do that. But the problem is we'll be allocating predefined amount of data. Predefined amount. And that's an issue because some subchunks are just filled with air. They don't have anything, but I will have prepared data for them. But let's try to prepare data for them here. How much? How much should I prepare? I think I've done something like this before and I've landed on a number that was close enough. But where? Chunk generator. Where? When here I have the data. Is chunk connected? Disconnect. Create chunk connection. If there's free space, here I create chunk data. how much space do I prepare? I think I have a limit somewhere. Okay, how many blocks we have in a subchunk? 16 times 16 times 16. This is how many blocks. And how many faces are we going to deal with? Let's... int max blocks is equal to... let's say... like this is the maximum blocks a subchunk can have. And so int faces is at the maximum we will need 6 times this faces. And then at the maximum each face is each face is 1 quad, so triangles is 2 times per face, and so triangle count is this. Here it's the indices are triangles. Oh, come on, don't execute this. This should be times 3. And here maximum blocks. Let's divide it by 2. Let's see what happens. And let's see it through here without only in the main thread. Only in the main thread. Yeah, it's working still. It's working. And then why when we generate the mesh it's rendering the sides? Why is it rendering the sides? Should be 1. Oh, here it's 0. Curl faces. I get it. Yeah, now faces are curled. Sure. And now let's go in the main and here clear it up. And now, okay, that is not the issue. Here I've removed the mesh preparation. Here the only thing that happens is I fill up the vertices and indices and set mesh generated to true. Okay, let's see here, trace lock info mesh generated like this. 1, 2, 3, 4, 5 mesh generated. And so do we get to go here? 1 only once. We got here only once. Can I look at all the subchunks? Can I look at all the subchunks? Here is the main loop. Here. So I reach here for all mesh generated, but here it's only once. God damn it. I'll leave it at here, maybe, because I cannot move on. That's fucking annoying, man. This was the worst possible case. Like, the whole stream blocked by one simple problem. That's it. The whole stream blocked. And because of that blockade, the whole stream was like ruined. Just because of this. Just because of this. That's why I'm annoyed immensely. Let's here have here. Let's go over them. Bool generated mesh equals here generated mesh. I want to go through them. I want to go through them. What's your issue? Mesh generated. I want to go through them. Here. Here. True. Is there a point where mesh generated equals false? Is there a point like that? Yes. Yes. There are meshes that are not generated. There are meshes that are not generated. And that's because it stops here. And that's because of the culling, and that's because it thinks all the neighbors are solid. It thinks all the neighbors are solid, except for the first subchunk. One of the subchunks was without issues. One of the subchunks was without issues. We could say that, okay, the problem is because the neighboring subchunks blocks are not generated, but I don't know what to do. Yeah, man, let's just stop this stream and like I'll figure out how to move on. I'm very annoyed.